Hi students, this is Neeraj Bansal and welcome to my channel Math Navigator. Today we are going to work on probability. See, probability is very important term which we use in real life daily. Like let's say your teachers must be asking you, what do you think you will get 7, or do you think you will get 6, or whatever. That means what is the probability of getting 7 or 6, right? Basically what happens, probability or rather experimental probability can be defined as the number of favorable outcomes over total outcome. I'll just explain you what does this mean when I say number of favorable outcomes over total outcome, right? Still, let's get so total outcome. Let's understand what does this mean. Number of favorable outcomes. Let's say if you toss a coin, right? So if you toss a coin, there are two possibilities: heads or tails. So your favorable outcome is head. So if I want to know probability of head, what are the what is the probability of head? How much is the number of favorable outcome? 1, and total possible outcomes are 2. So the probability of getting a head is 1 over. Why we call this experimental probability? Because in real life scenarios, what happens? Let's say you toss the coin 10 times. So according to theoretical probability, you should get 5 heads and 5 tails. Does that really happen? No, right? So that's why we call it experimental probability. But when you keep tossing the coin, like when you increase the number of events, the probability will match. Got it? So we call this experimental probability, or it is also called relative frequency. So if you see this term in your exams, don't get confused. This and probability means the same thing. Probability is nothing but chance, which is relative frequency. Then another important thing is how to be how do we find the probability? What are the tools with me? Number one, two-way table. Number two, I have tree diagrams. And number three is Venn diagram. Finding the probability is the main aspect. Like let's say if I'm saying, I'll explain you what is a tree diagram, what is a Venn diagram, and what is a two-way table, right? So let's say first I'll give you some simple examples, and then I'll teach you the whole theory, whatever is required in probability, and then we'll keep doing the questions. We'll finish this topic off in two videos, so you need to watch both the videos, because in the second video probably I will be doing only questions. Right, in the first video I'll try to explain you everything in a nicer manner, and of course even then if you find any doubt you can always contact me at on the number given at the bottom in the description box, right? So first let's talk about what is two-way table and how it is used. Let's say you toss two coins, right? Two coins means you are tossing a coin one after the other, right? So what happens, let's say on first time you toss a coin, it might be a head. Second time you toss a coin, it might be a tail, or vice versa, or what, two heads or two tails or whatever. So that means if I ask you what is the probability of getting two heads, that means on both the occasions you are getting heads. If I ask you what is the probability of getting one head, so that means you might be getting you are getting one head and one tail. It might be the first head, second tail, first tail, second head, or whatever, right? Or I can ask you what is the probability of getting first as a head. So all the possibilities, all possibilities is called sample set. What is the sample set for this? Head, 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 tail, tail, head, and tail. So this is the sample set for this event, right? So what is a two-way table and how it works? First, I'll explain you the two-way table. You can do both the tables like and you can solve the same question both with the two-way table as well as a tree diagram. I'll explain you both for this. So let's say I'm making a two-way table. So two-way table is something like this, right? So first you can write like on first coin you can get head or and a tail, and on the second coin also you can get head and a tail, right? So now my first thing is head head. I can get head head. I can get head tail. I can get tail head. I can get tail tail, right? Now I want to find the probability of getting two, which is how much? 1. And how many are to love 1, 2, 3, 4? So 1 over. Probability of getting head tail. If you are considering head tail and tail head in the same thing, then what is the probability? 2 over 4, which is half. What is the probability of getting two tails? Again, 1 in. So this is called a two-way table. I'll give you one more example, then you will understand it better. Then what is a tree diagram? I'll explain you what is a tree diagram. Now what is this? Is a tree diagram. This is like two branches. That means when you toss a coin for the first time, this is the first time you are tossing a coin. So what happens? It can be a head or it can be a tail, right? Now if you have now let's say suppose you there are both options, either head or tail. So if you get head, again you are tossing the coin, so you can get either head or tail. If you get tail, then also head or tail, right? Is this point clear to you? Yeah. Then what happens? There is one more thing which is called combined events. What do we mean by combined events? Combined events means the event is happening one after the other. So that means first coin is tossed and second coin is tossed. These are two combined events. So whenever we have combined events A and B, then probabilities are multiplied. Got it? So I'll just simply write a probability of getting a head, half. Probability of getting a tail, half. Probability of getting the head, half. Probability of getting a head, half. Tail, half. Half, half. So that means this is my possibility head, head. So I'll write head, head. I'll write the probability in different color. I'll write it. So I can get head, head. I can get head, tail. I can get tail, head. Or I can get tail, tail. Got it? So this is the thing. So probability of head, head is half times half. This is also half times half. This is also half times half. And this is also half times half. So this becomes 1 over 4. This also becomes 1 over 4. This also becomes 1 over 4. And this also becomes 1 over 4. So probability of getting head, head is equal to 1 over 4, which you get the same thing from here. Probability of two tails again is 1 by 4. Probability of head and tail again is 1 by 4 plus 1 by 4, which is 2 by 4, which is half. Got it? So this is how we do it. So that means this is how we do it with this Venn diagram, and this is how we do it with tree diagram. Got it? Now let's talk about, I'll give another example, right? Then you'll understand. So let's say, um, there are two things. I toss a coin and then rolled unbiased die. Die is 1, 2, 3, 4, 5, 6, right? So first I want to know what is my sample set, right? So what do we mean by sample set? Sample set means all possibility. Got it? Sample set means all possibility. So how I will work on it? So again, there are two ways. Either you can use the tree diagram or a mm, uh, or a two-way table. See, it's like this. You can solve it with both. But again, the thing is, you have to choose which is more convenient for you. Once I'll do this, then you'll understand what do we mean by convenience. Let's say you have to go 10 kilometers. There are two possibilities. Either you can go by the car or you can go um, by the cycle, right? So how do you prefer? Although both vehicles you will be able to reach your destination, but you will prefer car, right? Same way, if I'll use the two-way, let's say if I'm using a tree diagram, right? So let me use the tree diagram so that you can understand what I am. So when you are using the tree diagram for the 2 points, you will get this head or a tail, and then you have 6 options. You can get 1, you can get 2, you can get 3, you can get 4, you can get 5, you can get 6, right? And in the same manner, I'll just rather copying and pasting it. Rather, I should. So I'll copy and paste it here. Right. So basically, here I have head or tail, and here I have 1, 2, 3, 4, 5, 6. Here I have 1, 2, 3, 4, 5, 6. Although you can make it like a tree diagram like this, but that is very clumsy, right? Although it will give you the correct result, I'm not saying it will give you the wrong result, but that is not looking very nice. Instead, what you can do, you can do something like this. Perfect. Right. So here you can have head or tail, and tail, and here you can have 1, 2, 3, 4, 5, 6. So head and 1, tail and 1, head and 2, tail and head and 3, tail and 3, head and 4, tail and 4, head and 5, tail and 5, head and 6, tail and 6. Got it? So this is perfect, right? Now these are the possibilities. I can ask you many questions like what is the probability of getting tail and an even number? What is the probability of getting tail and an odd number? Like this. So these are the two methods of finding it. How do we use Venn diagram to solve probability? This I'll tell you with the question itself. And there are certain important terms which we need to understand, right? So we have already understood what are combined events. Then we talk about certain important terms. Number one, mutually exclusive events. Then we have independent events. Then we have conditional probability. And then we have additional law of probability. Right. So first we'll understand what is additional law of probability. Additional law of probability says probability of A union B is equal to probability of A plus probability of B minus probability of A and B. These things you have already done in the sets, but I have made one separate video on sets which you can see. You can do some questions on the sets, then you will become better, right? So this is what I have. This is the additional law of probability. Got it? Then we talk about, I'll explain you with the example what are mutually exclusive events. So what are mutually exclusive events? Let's say if I'm tossing, I'm rolling a dice. So if I'm rolling a dice, let's say I have event A is odd number or getting odd number. And event B is getting even number. I'll give you one more example, then you'll understand what is the mutually exclusive events and which are not mutually exclusive. Let's call it event C as getting a prime number. So first let's talk about event A and B. So can event A and B happen together? What does this mean? This means what I'm trying to ask is, let's say if I roll a dice, can odd and even number come together? No, it's not possible. Either it will be an even number or a odd number. So event A and B are mutually exclusive. Perfect. Right. So event A and B are mutually exclusive. Then let's talk about event A and C. So when we are talking about event A and C, that means getting odd number and being prime, right? This can happen. Yes, getting odd number and being prime. Yes, because a number can be 3, which is odd number as well as prime. So these are not mutually exclusive events. I hope you have understood the difference between a mutually exclusive event and not a mutually exclusive event. Now I'll talk about independent and dependent events. Independent and dependent events. What is the difference between independent and dependent events? This you will understand when I'm saying, let's say I have um, a bag of balls, right? In this, I have 4 red balls, right? And 3 green balls. Got it? Then there are two things, with replacement and without replacement. What do we mean by with replacement? That means you have taken out the ball from the bag, see it, what color it is, and then put it back. So the number of balls doesn't change. But without replacement means you have taken the ball out of the bag. Let's say you have taken out 1 ball and then you have kept it outside after seeing the color. Got it? So now I'll make a trigram for a situation like my make sample space for taking out the balls one after another, right? So I'll make with both with replacement. First, I'll make with replacement. So when I'll make with replacement, I'll just make it, then you'll understand it. This is my first ball I have taken out. This is my second ball I have taken out. Right, let me copy it and paste it for the two. Copy and here I will paste. Right, so this is with replacement and this is without replacement. So first of all, we need to understand one thing. If there are 7 balls, what is the probability of red? 4/7. And probability of green? 3/7, right? So let's take, if I'm taking the first ball as red and then green, then red and then green and then red and then green. So probability of red is 4/7. Probability of green is 3/7. Probability of red stays the same because you have replaced the ball. So it is 4/7 and green is 3/7. So probability of green, red is 4/7. Probability of this green is 3/7. So if you see, the probability of green as a second ball is stays 3/7 in both the cases, here and here. Whether it is independent of whether the first ball is red or the first ball is green. So these are independent events. Got it? That means green ball, getting a green ball in the second attempt doesn't make any difference whether in the first attempt you have got a green ball or a red ball. So these are two independent events. But if you talk about the second thing, let's do this as well. Then you'll understand the difference. Red, green, red, green, red, green. So my probability of red is 4 by 7 and green is 3 by 7. So let's say you have taken one ball out. Let's say it is red. So what happens? One red ball is decreased from the group. So the probability of the balls remains 3 by 6. And probability of green becomes 3 by 6. Right? Clear? Now, if the second ball is green, then the probability of red is 4 by 6 and probability of green is 2 by 6. So, in this case, if you'll see the green balls, right? So, in the green balls, you have got 3 by 6. Here, the probability is 3 by 6 if the first ball is red. But the probability of green ball is 2 by 6 if the first ball is green. So probability of getting second ball as a green depends which ball you got in previous. Got it? So these are dependent events and these are independent events. I hope everything is clear to you, whatever we have done today. Right, so these are the concepts which I've tried to explain you with by giving an example of everything. In the next video, I'll also make the next video on probability. In the next video, please see it for sure, because in the next video I'm going to do questions based on it, which is very, very important to do. And then I'll attach a worksheet also so that you can do it. Right, so we'll meet in the next video. In the meantime, please subscribe my channel.